Oh well, hello. So in this video I'm going to show you the new feature which I put in Chirp function, with which you are allowed to choose a polynomial of any degree for the amplitude of the Chirp function for the fitting. So let's just start it from Eclipse now, and you will have to first load the directory of the text files, and I'm just going to go to one of these directories where the file is here. And after this you will see that now it has a polynomial amplitude and a random amplitude. So the polynomial amplitude allows a polynomial of any degree for the amplitude function of the chirp function. So chirp function consists of a cosine term and there's an amplitude, and either the amplitude could be random, in which you had something which was there before. So if you click this will be disabled. You won't be able to click here, and click back, and then you can choose a polynomial of any degree. So let's say polynomial of degree 2, and all of these parameters are the parameters for the chirp function: the frequency omega 0, the expected width of the peak omega 1 minus omega 0, and the max iteration for the Levenberg-Marquardt solver, which is actually doing this fitting of intensity profiles using this chirp model. And in this case I'm going to use a polynomial model. Now you just have to click and it will start to fit, and this wouldn't take much time because you have only a polynomial of order 2, so it's quite fast. You'll see the updates as they happen, and when it's converged it would stop the iteration, or when it hits the max iteration number the iteration would be stopped, and then you would be able to see the results of the fit. And if you're not happy with the results of the fit, you can go one higher order in polynomial. So this is the results which you get. So this is the function which it fitted. So with this 3 degrees of freedom which the amplitude has. Now if I suggest 0, then it would be probably have a hard time getting any of the features of this, and yeah, this is how it gets. So yeah, so you can see you have to choose this polynomial of this degree, so if you want to get all the capture all the features of your data. This is polynomial of order 6, and it starts a bit weird, but yeah, those are some of the coefficients which you have to initialize this polynomial with, and now it is able to capture some more features which your polynomial of order 2 wasn't able to capture. And then you can do this for all of the files. You can auto fit with the preset parameters you have, and it will fit this function with these predefined values for all of the files which you have loaded in this, which we had in this directory. And if you're not happy with this, you can always go for the random amplitude, where it would be trying to it would ask you for a good initial guess for the frequency which you get from Fourier transforms, and then you have to, and it will find the amplitude. It will assume that the amplitude is a random function for all time points, and it will find that value for each of the time point, and it would make a perfect fit and would give you a perfect chirp function which would explain your data. And if you don't get a perfect fit with that, which means that would mean that your frequency value that you chose initially wasn't the correct one. So you have to be a bit careful about how the frequency values you enter when you're using the random amplitude chirp function. So try it out. If you have any questions, don't hesitate to ask me. And if you this want a link for downloading the software, just write in the comments below. Cheers.